Good morning, children. Today in chapter 6 we are going to discuss about the tangents and normals. So this is the second subtopic of application of derivatives, and prior to this we have already discussed about increasing and decreasing functions. Now the further extension is tangents and normals. So what we are going to learn today in this topic? So we will be learning about definition of tangent and definition of normal, in slope of tangent and slope of normal, equation of tangent and equation of normal in Cartesian as well as in parametric form. Then we will discuss about angle of intersection of two curves. Then finally we will be solving some of the problems on tangents and normals. So at the end of this session you will be able to find the slope of a tangent and slope of a normal. Also you can find the equation of a tangent and equation of normal in both the forms, means in Cartesian as well as in parametric form. Also you will be able to find the angle of intersection of two curves and solve the problems on tangents and normals. And prior to this, you have already studied in chapter 5 about differentiability, the various rules associated with this differentiability, like your sum rule, difference rule, product rule, quotient rule, chain rule, and also you are aware of the procedure for differentiating various functions like polynomial functions, logarithmic functions, exponential functions, etc. Now coming to the definition of tangents. What do you mean by tangent? This tangent is a straight line which touches a given curve exactly at one point. We call it a tangent to that curve at that point. So here in this case we find that this red line touches this curve exactly at one point. So it is a tangent to the curve at that particular point. Now normal. Normal is a straight line which is perpendicular to the tangent at the point of contact of the tangent. That means the point at which the tangent touches this curve. If at that point we draw a line perpendicular to the tangent, then that becomes the normal. Now how do you find the equation of tangent and equation of normal? As you have already discussed, tangent is nothing but a straight line. Normal is also a straight line. Now we know how to find the equation of a line. So to find the equation of a line, we require two things. First thing, the point at which we need to find the equation, and also the inclination of that line. That means it is the slope of that line. So for tangent, if we can find the slope of the tangent at the given point, then we can easily find the equation of tangent, and same is the case for normal also. Now the question comes, how do we find the equation of tangent? Suppose here the tangent is drawn at point x1 y1 to the given curve y is equal to fx. So first of all we have to find the slope of the tangent. So in general the slope of a curve is given by dy by dx. So by differentiating the curve we find the slope of the tangent, and putting this value x1 y1 in that slope we get the slope of the tangent to that curve at that point, and let it be named as m. So dy by dx at the given point x1 y1 becomes your m, slope of tangent. So equation of tangent becomes y minus y1 is equal to m into x minus x1. This is the equation of the line in general in one point form. So since this tangent is a straight line and it is drawn at point x1 y1 with slope m, then equation of tangent becomes y minus y1 is equal to m into x minus x1. Similarly, the normal is the line which is perpendicular to the tangent, and as we know, if two lines are perpendicular, product of their slopes is equal to -1. Already we have found the slope of tangent as m, that is dy by dx at the point x1, y1. So definitely the slope of normal becomes minus of 1 by m. So equation of normal becomes y minus y1 is equal to minus 1 by m into x minus x1. So here is a particular case. If dy by dx at the given point is 0, that means slope of tangent is 0, then the equation of the normal would be x is equal to x1. Now some of the important points that needs to be remembered for getting the equation of tangent and equation of normal. Some of the conclusions here are dy by dx at the point x1, y1, if it is 0, then the tangent is parallel to x-axis, and conversely, if the tangent is parallel to x-axis, then its slope must be equal to 0, because we know if two lines are parallel, then their slopes are equal, and we know slope of x-axis is 0. So slope of tangent is equal to 0 means slope of tangent is equal to slope of x-axis. So naturally the tangent must be parallel to x-axis. If the tangent is parallel to the line ax plus by plus c is equal to 0, then the slope of the tangent becomes minus of coefficient of x by coefficient of y, that is minus a by b. This is the slope of a line in general. Similarly, if the slope of tangent at x1, y1 approaches to infinity, then the tangent is perpendicular to x-axis. If the tangent at x1, y1 is equally inclined to the coordinate axis, then the slope of the tangent will be plus minus 1, because theta must be plus 45 degree or it is 135 degree, and accordingly the slope, which is equal to tan theta, becomes plus 1 or minus 1. If the tangent makes equal non-zero intercepts on the coordinate axis, then slope of the tangent must be equal to minus 1. And if the tangent cuts off from the coordinate axis equal distance from the origin, then slope of tangent must be plus minus 1. Next comes your angle of intersection of two curves. The definition says the angle between two curves is nothing but the angle between their tangents at the point of intersection. Now here in the diagram we find the two curves intersect each other at point P. So we draw a tangent to the first curve at point P and a tangent to the second curve at point P, and the angle between these two tangents is called the angle of intersection of the two curves. So here m1 slope of the tangent to the first curve, it is a derivative of f1x at x is equal to x1, and m2 derivative of the second curve at x is equal to x1, and both m1 and m2, that means both the slopes must be finite quantities. Then the acute angle between the two curves is given by tan theta is equal to m1 minus m2 by 1 plus m1 into m2 with absolute value. That means theta becomes tan inverse m1 minus m2 by 1 plus m1 into m2. Now with this much of theory, we'll discuss about some of the problems on tangents and normals. So whatever theory portion we have discussed about the slope of a tangent, slope of a normal, equation of tangent and equation of normal, on this basis we'll solve some of the problems. Now your example 1, consider the curve given by y is equal to fx, which is equal to x cube minus x plus 3. Now question is, find the equation of tangent and normal to the curve at the point 1, 3. So we have to find the equation of tangent and equation of normal to this curve at this point. So for this we first of all find the derivative f dash x. So it is ddx of x cube minus x plus 3, that becomes 3x square minus 1. Now we put the point 1, 3. Here y coordinate is not there, so we simply put the x coordinate, x is equal to 1. So f dash at x is equal to 1 becomes 3 into 1 square minus 1. That means 3 minus 1 is 2. This is now the slope of tangent to this curve at the point 1, 3. Then equation of tangent, we know it is y minus y1 is equal to m into x minus x1. Here y1 is 3 and x1 is 1. So the required equation of the tangent becomes y minus 3 is equal to slope is 2 into x minus 1, which on further simplification becomes 2x minus y plus 1 is equal to 0. Now coming to the equation of normal. So first of all we find the slope of normal. Now the slope of tangent is 2. So slope of normal becomes minus of 1 by m, which is equal to minus 1 by 2. So in decimal form it is minus 0.5. So equation of normal, y minus y1 is equal to slope of normal into x minus x1. So on simplification this becomes 2y minus 6 is equal to minus of x plus 1, that is x plus 2y minus 7 is equal to 0. Then one more question. Example 2. Find the slope of tangent to the curve x is equal to a sin q theta and y is equal to a cos q theta. So we have to find the slope of tangent in general to this curve. Now here we find that the curve x is equal to a sin q theta and y is equal to a cos q theta. They are in parametric form. Here theta is the parameter. Now to find dy by dx, that means slope of tangent, we have to differentiate x with respect to theta because x is a function of theta, and also we have to differentiate y with respect to theta. So differentiating x with respect to theta, we are getting dx by d theta is equal to a into d theta of sin q theta is 3 sin square theta into cos theta. So that becomes here 3a sin square theta into cos theta. Similarly, dy by d theta, it is minus 3a cos square theta into sin theta. So on division, dy by dx becomes dy by d theta divided by dx by d theta, that is minus 3a cos square theta into sin theta divided by 3a sin square theta into cos theta. So on simplification this becomes minus cot theta. Now one more example, example 3. Prove that the tangent lines to the curve y square is equal to 4ax at points x is equal to a are at right angles to each other. So we are given only the x coordinate of the point which is equal to a. We have to find the angle between the tangents at this point x is equal to a to the curve y square is equal to 4ax. Now we have the equation of the curve y square is equal to 4x. Now putting the x coordinate which is equal to a, we are getting y square is equal to 4 into a, that is 4a square. That means y becomes plus minus 2a. So accordingly we are getting two such points. One is your point a to a and the other one is a minus 2a. Now we have to find the slope of tangent to the curve at this point a is equal to 2a and at the point a is a minus 2a. Then if the product of their slopes is equal to minus 1, then the two tangents will be perpendicular to each other. So now differentiating the curve with respect to x, so it is dx of y square is equal to dx of 4ax, that is dy by dx becomes 2a by y. dy by dx becomes 2a by y. Now putting the y coordinate y is equal to 2a, so dy by dx becomes 2a by 2a which is equal to 1. So that means this is the slope of the first tangent. Similarly, putting the y coordinate minus 2a, we are getting slope of the second tangent is minus 1, which is your m2. Now on multiplication, the product of the slopes, that means m1 into m2, becomes 1 into minus 1. That means it is minus 1. That means we can say the two tangents are perpendicular to each other. That means they are at right angles to each other. Now, dear children, we have some of the questions which is assigned to you as your homework. So please try to solve these questions. Means these questions are just similar to the questions which are already been discussed here. So the first question is, find the slope of tangent and slope of normal to the following curves at the indicated points. So y is equal to 1 by 3x minus 2 at the point 1, 2. Similarly, x is equal to a sin q theta and y is equal to b cos q theta at the point for which theta is pi by 4. Then find the equation of tangent and equation of normal to the following curves at the indicated points. Y is equal to 1 by 3x square minus 2x plus 4 at the point minus 1 comma 2, and x is equal to a sin square theta and y is equal to b cos square theta at theta is equal to pi by 4, and x square by a square plus y square by b square is equal to 1 at the point x naught y naught. So thank you children.